Hey guys, so we're going to be going over some. Okay, yeah, so we're going to be going over. The goal is to do 100 questions, and they'll be from like different sources. So some will be from amctrainer.com, some will be from Alchemist. So there are a lot of different places like that. I'll try to do 100 questions in total. I'll keep track of that over here. And let's begin. So our first one is a circle has a center -10, -4, and has a radius 13. Another circle has this. The line passing through the 2 points of intersection of the two circles has x plus y equals c. That's the equation. And you have to find c. Okay, so we can say that x plus 10 squared plus y plus 4 squared equals 169. And for the other one, we have x minus 3 squared plus y minus 9 squared is equal to 65. So if we expand them, we should be able to get, we should be able to get our solutions. And then, yeah, let's do that. So first we'll get x squared. This is the top equation. X squared plus 20x plus 100 plus y squared plus 8y plus 16 equals 169. Here we have x squared minus 6x plus 9 plus y squared minus 18y minus 18y plus 81 equals 65. Okay, so let's subtract one from the other. The way we'll do that is we'll just do, let's call this equation 1, let's call this equation 2. We'll do equation 1 minus equation 2. And the reason is because I'm actually already noticing something there which should work out nicely for us. Okay, so when we do the subtraction, the x squares will cancel out and we'll get 26x. We'll have plus 109. Okay, plus 109, but there's also plus 81, which makes it 109. So 190 plus that makes it 206, I think. Not too sure. One second, actually. 206, that's correct, right? 109 plus 81, 190, 206. Yeah. Oh, wait, sorry, we're subtracting it. My bad. That gives us 26 then. Okay, my bad about, yeah, 100 minus 9. So it's 116 minus 90, which is 26. Then we have plus 26y. And this is all equal to 169 minus 65, which is 104. If we cancel out 26, if we divide everything by 26, we just get x plus y. This is 4. You subtract 1, you get 3. So the answer should just be 3. Okay, 3, so it'll be A. Yeah, correct. So that's the first question. Wasn't too bad. The only thing that might be a problem is that AMC trainer, there might be a way, I'm not sure. But I don't think you can like change the difficulty. So some of them might become like pretty hard. And I might not be able to do them. So we'll see. Okay, that's the first one. Let's get some more space up here, up over here. Let's go. Let A, B, C, and D be positive integers such that GCD of A and B is 24, GCD of B and C is 36, GCD of C and D is 54, and the GCD of D and A is between 70 and 100. So the greatest common divisor is 54. Uh, okay. Which of the following must be a divisor of A? So the GCD of D and A will be um what's a GCD of 24 and 54, right? It'll be a multiple of that. So 54 and 24, if we take those two, maybe I'm using the wrong terminology, but I think So basically 24 is equal to what, 2 cubed times 3, right? 54 is equal to 2 times 3 cubed. So if we just take 2 cubed and 3 cubed, um, well, that seems wrong actually. One sec. So it's 8 and 27, right? Uh, this seems pretty hard. All the numbers are prime, so that's kind of the problem. But let's try it. Let's see. So a is a multiple of 2 cubed times 3, and d is a multiple of 2 times 3 cubed. We don't really know about the other ones. Well, we know that a. Oh wait, actually, I should probably say like times x, because there might be some other things there that it's a multiple of. Same with this. Now the greatest common divisor. Well, we know that there's going to be a 2 and there's going to be a 3, right? So it's going to be 6 times something. Let's call that z. So it's going to be a multiple of 6, the GCD of d and a. But what exactly will it be? That's kind of that's what we need to figure out, right? And maybe not for that, then I think we need to use the clues that we've been given on the side there. The clue that GCD of b and c is 36, which is 2 squared times 3 squared. And if that's the case, then we know that b is 2 squared times c times 3 squared. So this is a, this is d. B is equal to what, 36. This should be 24x, this should be 54y. This we'll say alpha. So this will be 2 squared times 3 squared times alpha. Okay, and let's do the same thing with c. Um, well, c will just be the same thing then, right? Well, actually, b also has a cube in it. Obviously, we know that much. Since it 24 is the greatest common divisor of a and b. And similarly for c, we can then say c is equal to 2 squared. So it'll be, so what does this become? 72. And c will become 2 times 3 cubed times another 2. So it'll be 27, 54, 108. 108 beta, beta, whatever, which should be 2 squared times 3 cubed times beta. Okay, we've got this now. It looks a lot very messy, not very neat, but maybe we can still figure this out, right? We know that. What are the other primes they can have? Right? Like, what are the other prime numbers that can be in their factorization? Obviously, we know there can't really be another 7. We know that in D, there can't be another 2, right? And similarly in A, uh, what do we know in A? In A, we know that there can't be another 3. Okay, well, first of all, we know it's not going to be 17. Let's maybe do that instead. So it's not going to be 17. That's because 6 times 17 is too much. Oh, wait, I'm so stupid. And then actually, it can't be 5. That will be too little, right? 7 will be too little, and 11 will be too little. Because 6 times any of those numbers will be too little, and if you multiply it with another, with another one of them, it'll still be too less. So I think we'll have to say D. It could be a wrong guess. So D is the only one. Like 6 times 13 gives you 78, which is between the 70 and 100 bounds. None of the other ones are. Okay, I'm going to take a look at the solution here. Okay, I think you just do look at the. Okay, and then it seems that the GCD of B and C was just like uh, a trick there. Okay, let's mark this here as well. So this is our second question. I know it's going pretty slowly, but there are enough tricks to make it, speed up a bit. I can always do some easy questions if I'm like taking a long time. I don't want to do that, but in case I have to, I'll do it. Okay, now this one. So let's see. 1-inch squares are cut from the corners of this 5-inch square. What is the area in square inches of the largest square that can be fitted into the remaining space? Okay, so 5 inch. So it's obviously you can have 4 by 4, right? Sorry, yeah. If you're cutting, oh wait. It's a bit trickier than I thought. Let's draw it out here. So our square isn't going to be, the and this so each of these is 1/5. We could have a square that just goes like right here, but that's only going to be 9. So we definitely don't want it to be like that. That's too small. And we can obviously do diagonal squares, which is probably the idea, right? So this height is 5. How could we do that though? Like we could go from here and just connect these edges, which should work, right? I guess that might be one idea. Another idea could be to go from, maybe widen it out, I guess. I'll put this in red, maybe. Okay, in red. Like go from here to here, from here to here, here to here, and here to here, which it might be the same size actually. I'm not sure. But we'll figure that out, I guess. So yeah, let's see then. Let's do our first case like with the black square. Okay, we know that this is going to be 5-inch square. So this will be 5/2 and 5/2. So this will be 5√2/2. When you square that, you get 25/2, which is 12 and a half. So that's definitely possible. So okay, now if we know that, obviously it's not going to be A. That's definitely wrong now. What else can we do? We can go from like here to here and just sort of try to connect it and see what's how long that can be, right? Because this is one and wait. Okay, let's do it like this. So this length is one. Let's call this length x, right? Then what? And we want it to be symmetric because it has to be a square, right? So this will be x. This small length over there. So this length will also be x. This will be one as well, right? And then this will obviously be one too. So now we just need to find an equation and just make sure that they don't intercept, right? How am I explaining this? Okay. And then the length of this thing over here will just be um we want to take this length, and then basically this length squared plus this length squared will give us the area because that will give us length squared, which is the area of a square. We can go over that part later, then that will just be 4 minus x times 1 plus x, right? This is 1 plus x, this is 4 minus x. And so that's the expression that we have right now. We now need to find out like the smallest possible value of x, or well, any value of x basically that will work. and for that we need to have this, and we just want to make sure it doesn't like go through that square, right? So let's call this the origin 0 0. uh Actually, wait. Okay, to make it as efficient as possible, what we want is for our line to go and touch the square right here and then pass through like this, right? Something like that. And so then this will be the x value, this will be 1. So and they're similar triangles, right? These are both right triangles. So this is, wait, it's a bit messy now. Let's just redraw it here. This is a 1 by 1 square. Right? This is 1, 1. This is x, so this is 1. And you can continue it like this. Right now for this square, we want an x over 1 ratio, right? This part is now x over 1. So we want x to equal x plus 1 over something, over y. So y will just equal x plus 1 over x. Wait, that seems wrong. Yeah, no, that's correct. So that's 1 plus 1 over x. So this height over here has to be x plus 1 over x. We've already got a 1 over there. So we'll do this minus 1. Uh, okay, wait. Minus 1. Let's see. 1 second. So we've got a ratio of x over 1 here. We have x over 1. So this height over here, from here to here, which we already said is equal to 4 minus x, should equal x plus 1 over x. Okay, 4 minus x should equal x plus 1 over x, basically. And then I think we can just solve that and find the value from there. Basically solve for x and then solve it and then figure it out from there. So we get 4x minus x squared equals x plus 1. If you get x squared minus 3x plus 1 equals 0. That it looks a bit messy. And yeah, you can't really simplify this. It's going to have a radical in it. Right, let's see. 3 plus minus the square root of 9 minus 4. So 3 plus minus square root of 5 over 2. Actually, I don't even know if it's plus or minus here because they're both positive. 1 sec. Okay, wait, this is a bit worse than I thought. Yeah, so this height, this is 1 plus x. And so this part is just 4 minus x. But we also said, um, since this is x, we also said that this is just x plus 1 over x. So we equated them. We got 4x minus x squared equals x plus 1. And yeah, it's not factorable. The roots will be 3 plus minus 9 minus 4. So root 5 over 2. Okay. I don't think either of the answers are looking too good here. So we might have to. Okay, wait, let's expand this and just see what we get. We get negative x squared plus 3x plus 4. And we already know that negative x squared plus 3x minus 1 equals 0, or basically negative x squared plus 3x equals 1. So this equals 5, right? Wait, do that, uh, that's obviously not possible though, right? 3 plus root 5 over 2, if you square that, so we're doing negative x squared plus 3x, which we already know is equal to 1. You do plus 4, which makes it 5. That's the area. So that's wrong. So I'm just going to put B and guess that it's wrong. Let's try C. Okay, this is correct. This is correct. Let's see why. Okay, they're talking about the four big triangles over here. Right, that seems fine. Okay, so we read the next solution and see. Okay, wait. So I think what this solution is saying is that you know that there's a minimum area of 9 if you just do the 3 by 3 square, and then out of whatever's left, you can just take half, like they're showing with these triangles. So basically, in total, with the 9 that are already in the big square, then there are 4 from outside. So that's 13, which leaves 12. You can take half more, so it's 9 plus half of 12, 9 plus 6, or 15. Okay, that's fine. Okay, these are getting pretty hard, I think, right? Like late questions, 12B 17. So I'll leave that for now. Let's do some alchemist till then. We've still only done two questions, so this is going pretty badly. Let's change that and do several here. Okay, so first one. The sequence 12, 15, 18, 21, and so on consists of all positive multiples of 3 that contain at least one digit that's a 1. What's the 50th term of the sequence? Okay, so after 81, the next one that has a 1 in it won't be 91, it'll be 102. Okay, so we've got 12, 15, 18, 21, 51, 81, 102, 105, and so on. Okay, so each 101 now. The 50th term of the sequence. Right, so 1, 2, 3, 4, 5, 6. There are 6 of these that are before 100. So if you want to find the 50th term of the sequence, that's the same as finding the 44th term of this sequence. Right, the 44th term. The only problem is I don't think there aren't even a 44 terms over there. They're actually going to be 33. Right, from 102 until 198, that's 33 terms. So that's 33 more. So it'll be the 11th term starting from 201. Okay, you have 201, then you have 210, then you have, right? Okay, wait, what am I doing? How many are there going to be? How many multiples of 3 are there going to be that like in the 100, right? Like from 100 to 200, there should be 33 of them. There are 6 before that, so that's already 39. So it should be the 39. Yeah, so it should be the 11th term over here, in this sequence over here. So we have 201. This will be the first one. Then 210, 213, 216, 219. Then we have 222, 225, 228, and 231. And now we'll go every 30. So from 231, it'll go to 261 and then 291. Um, and we can actually continue that. So 291, 321, I think. And how many is that? This is 1, 2, 3, 4, 5, 6, 7, 8, 9. So it'll be 351. Wait, no, sorry. We've got actually before this, after 291, before 321, there's going to be all the 310 ones, right? So there's going to be 312, 315, and then 318. And then after that, if you have to, 321 too. Okay, so let's quickly count everything now. We had 1, 2, 3, 4, 5, 6. So there were 6 before that. Then there were 33. So that brings it to a total of 39. 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50. So it should be 318. Okay. Done. So let's go back to the black pen. This is the third question. So one gear turns 33 and a third times in 1 minute. Another does it 45 times. Initially a mark. After how many seconds will the two gears next have both their marks pointing to north? Okay, so how long does it take? Let's see. So how long does it take each of them to do one? Right, like 60 seconds. So, and you're taking 33 and one third times in 60 seconds. So let's just do it in how many seconds does it take for one turn of a gear? Right, so for gear one, let's make some space here. For gear one, oh, no, wait. For gear one, we have 33 and one third, which means it's 100 and 180, which means it takes 1.8 seconds. For gear two, you can do 45 in 1 minute, which means it's 45 out of 60 over 45, which is 4/3 of a second. And okay, let's if we're doing it in thirds and let's in fractions, let's write this as a fraction too. 1.8 is 9 over 5, right? Let's put them both in terms of 15ths then, right? So this will become 27 out of 15, and this one will become 20 out of 15. And now we basically just take the LCM, right? The LCM of both of these, which will give us, wait, what are we trying to do here? We're doing, so it's 100 and 180, which becomes 180 over 100, which becomes 9 over 5. The other one becomes just 60 over 45, which is 4/3. So now we can just take the LCM, which will be 20 times 27 over 15, right? Which becomes, so this cancels out to become 9, and then that will make this 5. This becomes 4, canceling out with this, so 36. But I don't think that's a, okay, it is 36. When A is written in base 9, its last digit is 5. When B is written in base 6, its last two digits are 5, 3. Okay, first of all, let's mark that question which we just did. So, fourth question, very slow. but we'll pick up pace now, don't worry. So okay, a is equal to like some multiple of 9, so 9x plus 5. B is equal to uh basically it's 33, right? And that's all we really need to care about. So this will be basically if the last two digits are, that means it's 33, and then this one is, what am I saying? This is 33 plus 5, which is 38. If you want to write this in base 3, right, like what's the remainder when you divide it by 3? It's just 2. And then before that, the maximum number you can have is 2. So it'll be 22. 2, 2. You can't have anything bigger than 2, and you need something bigger, obviously, to represent a number bigger than, uh, to represent a number as big as 38. Or it could be A and B could be, oh, sorry, it's A minus B. Okay, wait. Assume A minus B is positive. Okay, see, I almost did A plus B, so I'm glad I didn't submit anything. It's A minus B, so it's going to end in a 2, right? And then, uh, what else could we have then? It's going to end in a 2 because it's 5 minus 3. But we can also have, like, um, we have some 9x plus 5 minus 33. So that makes it, what does that make it? It makes it like 9x minus 28. Let's say that x is just equal to 4, right? We know there has to be some answer, so we can just take any. We know that there's exactly one answer for this, right? There's room for only one answer, so we can just say that x equals 4, which makes this 36. 36 minus 28 is 8, so it will be 2 2, right? And okay, coincidentally, it is the same answer as before, but we got lucky with like with respect to that. Okay, fifth question. Where's the thing? Over here. Okay, let's continue now. If AB is a probability that the reciprocal of a randomly selected positive odd integer less than 20, then gives a, oh, I don't want to do this. Randomly selected positive odd integer gives a terminating decimal with A and B being relatively prime positive integers. What is A plus B? So how can it be a terminating decimal? Only if it's, actually I don't really remember the rules for that, for terminating decimals and stuff. Let's leave this. Let's do some for the win. Okay, I'm going to count these questions because these are like probably the easiest ones, but they're still good. So whatever, that doesn't matter. I'll do 12 questions, 45 seconds, composite. If no one joins, that's fine. I can do it on my own. Anyway, that's fine. If any of you want to join, obviously you can do that too. Right? Just go to this link, the for the win link, and then you can join the game. Okay. I'll start this one on my own though, for the sake of time. Okay, so this will be written 16, 26, 36. How many times is that? It'll go from 16 to 96. And this includes 66 because 66 will get included twice. So this becomes a total of 9 plus how many are there in the 60s? From 60 to 69, that's another 10. So this should be 19. Okay. I might not explain in the future because there's not much time. Should just be 3 factorial, right? That's supposed to be a 3. 90 because the first one can be 9 digits, second one can be 10, and the other two are decided. Wait, this is wrong. I think it's n times in a quadrilateral. How much is it? It's 4 times 1 over 2. So in a pentagon, it'll be 5 times 5. It might just be 5 actually. I'm not sure. Yeah, I thought I misremembered the formula. 7. Okay. This is a long question. Triangle ABC, AB, the artery DC, whatever. Okay. 7 AD is 24. The new triangle is then rotated. The process creates 24, 24. Okay, 24 times 24. Sorry, 24 plus 24. So it should be like 24 times 7, which is 140, 168. Okay, I don't know if I fully understood the question, but seems right. Uh, and the numbers, if they're all odd and you add them up, it should just be 0. I don't think yeah, 3 odds will always be odd. And its midpoint is 6 comma 2. So what's the other one? It'll be 7 and then 7 comma negative 2, which means it'll be 5, right? Let's just check once. We've got time for this. So 7 comma 2, 5. Yeah, 5. Find the residue mod 14. First of all, 182 is a multiple of 14, 196 minus 14. So it'll be minus 7 plus 3, right? 1 second. Minus negative 15 is just negative 1. So times 7, negative 7 plus 3. Oh, wait, negative 7 plus 3 is negative 4. So it'll be 10. Okay. Express 10% of 30% of 50. So it'll be 5. 30% of 5 is just um 1.5, right? Wait. Express 10% of 30%. So 10% of 50 is just 5, and then 30% will just be 1.5, but it seems a bit off. Okay, fine. Okay, for 20 kilometers. So it takes half an hour plus another half an hour plus for 15 minutes. So plus 3/4 of an hour plus 1 hour plus 1/4, which means it's a total of 2 hours. How much, like what distance does it do? So it'll do 40 kilometers per hour for 20 kilometers. So okay, 20 kilometers plus 25 plus 45 because it's 60 kilometers per hour plus 48 times 1/4. So plus 12. If you add this stuff up, it becomes 45, 90, 90. So 102. Okay, it should have been 51. I think it would have been 51. Find the coefficient of x when you do this. Okay, there's nothing in the first term. It's negative 3. Negative 3 plus 8, so it should be 5. Okay, I'm pretty sure 11 was... Okay, question 11 should be 51, I think. I don't know though. Yeah, it was. I was like, just a few seconds too late, but that's my fault. Okay, I did 11 questions here. So obviously, this is what I was saying when I said I can make it go faster or slower. Right? Like very quickly, we were just able to do 11 because these are much easier questions. I don't want to do another one of these right now. Maybe I'll do it in some time again. But not now. Anyway, let's continue. We'll take some. Let's change the topic actually. We can do. Let's see. Actually, there's nothing I want to do in pre-calculus now because this sort of stuff will get a bit harder. Uh, this sort of this stuff is quite a bit harder. I don't want to really do that. So let's instead maybe tone it down and do some intermediate algebra. To be honest, I forgot a lot of this stuff as well. So let's do this. Some of these should be easy, hopefully. Let's try. Okay, complex numbers right off the bat. So that's not okay. Wait. I think we can do this actually. Right. So we can say since I given a plus b plus c, a b c, and that it'll be a cubic thing. I think. So we can say it's x cubed. Then we have minus x squared plus x uh minus 1, right? Which seems, wait, that seems correct, but I'm not too sure. And then yeah, obviously you can then factor this to be x squared times x minus 1 plus, wait, this seems wrong to be honest, but no, this is correct. And then just plus x minus 1. So this becomes x squared plus 1 times x minus 1. So one of the roots is just 1. One of them will be plus I and one will be negative I, right? Let's see. Okay, perfect. So it's going to be in any order. So 1 I and then negative I, hopefully. It's supposed to show me that latex pop-up, but no. Okay. That's one more question. Find the number of ordered triples that satisfy this. So one thing we can do is just and notice that we've got some weird stuff going on with the z, right? Z is always causing some trouble for us. So let's just say that let's add the question first, the one we just did. We're just about 17% done, so like 1/6, not too bad. I think if it continues going this poorly, we'll just do 3 or 4 more for the wins and get back on track. Anyway, let's say that a is equal to negative z, right? Then we've got x plus y plus a equals 0. We've got, now this is important. So we've got xa plus ya plus xy is equal to negative 27. And then same thing. Over here we will have, let's see, it'll be negative xya is equal to, wait, no, we just want negative 54, and then this will be positive. Okay, we've got our same Vieta's formulas stuff now. Now ignore the xyz variables here. Let's instead go to just x. Let's just create a new function now. X cube. This sum is going to be negative, so it'll be, oh, there is no negative. This is a bit weird. Um, we'll have, so it will be minus an x squared term plus the uh x term, so it'll be minus 27x unless I'm wrong. And then it will be minus that, and then it will be plus 54 equals 0. Okay, and so Okay, I think I'm gonna have to time out Ishan Agarwal. I don't really like what he's writing there. Let's see, how does this work? There, I'll give him a 24-hour timeout. Okay, good. Now, actually, let's see, how many roots will this have? Obviously, it'll have three roots, but will any of them be complex? We can, kind of graph this. Okay, for any negative number, this will be, let's just guess 3 for now, and then later, if we have to, we can guess. Okay, wait, first of all, there can't be a complex root on its own. So, there'll be at least, there'll be an even number. There'll be 2, 4, or whatever, because they come in pairs. So we can either have one real number or three real numbers. So let's guess 1 at first, and now let's guess 3. Okay. Yeah, wait, we got the same thing. I just didn't factor it because I didn't do it proper. I don't know how to. Anyway, okay, we got the roots there, so that's fine. Okay, continue. We technically got that correct as well. So let's mark that there. Um, the equation has real roots r, s, and t. Find the area of the triangle with sides r, s, and t. Okay, that's a good question. I'm pretty sure for this we'll use Vieta's formulas. Sorry, Heron's formula, which is s times s minus. Do we actually have to find? No, no, this seems wrong though. Because for this we'll actually have to find them. I'm pretty sure. Like actually find the roots, which I don't want to do. Um, First of all, I shouldn't be writing s here because there's already an s root. So let's change it to something interesting like q, q minus s, q minus r, q minus t. Q itself is just going to be like the sum of all of them over 2. Well, actually, this is just kind of stupid if you ask me. I don't want to do this, but um, fine. The sum will basically be 4, which means that q is 2. Okay, wait, that works out fine then. We have the square root of 2 times 2 minus s, 2 minus r, 2 minus t. Now I guess you just have to like kind of find the distribute this out, which will give us. So when you do it with these two, you get 4 minus so minus 2 r plus s plus rs. When you multiply that by 2 minus t, we end up getting, so the 2 will make this 8 minus 4 r plus s plus 2 rs. Then we have again, like, now we do it with minus t, so we get minus 4t. Wait, negative 40 plus 2t times r plus s minus trs. Okay, and this ends up simplifying, it seems, pretty nicely because we just have, let's simplify this way. We have 8, and remember, this is still all like we have to take the square root of all this, right? So, yeah, and it'll end up being not too clean. Anyway, we have basically 8 minus 4 And then there we have r plus s plus t, right? That's fine. We know that that is 4 anyway, so that's good. Then we have plus 2 times, and then this what I was a bit confused about, but it makes sense now. Rs plus st plus rt. Right now we've got that thing as well. Um, so all of this is accounted for, and then we just have minus trs, right? And that's the thing. That's why it's Vieta's formulas, because we know all this stuff. R plus S plus T is what? That's 4, right? So it's negative 8 minus 16, so negative 8 plus 2. Wait, it's minus 2. No, it is plus 2. This will be just 5. So this will become 5. So this becomes 2 times 5, which is 10. Minus, and then TRS becomes. Wait, this seems a bit. Mm, the hell. Minus 4, R plus S plus T is negative 4, which means it's 4. So then 5 becomes positive, it becomes negative. So it's minus 19 over 10, which seems bad, but whatever. Let's see. Okay, then this becomes very weird because negative 8 plus 10 becomes 2, 2 minus 1 by 9 becomes 0.1. So it should be the square root of 0.1, which means it's this root 10 over 10, which seems a bit small for me. But let's just try it and see. Okay, did I do the formula wrong? That's possible. Oh, wait, it's all multiplied by 2. That's the thing, right? Stupid. Now the thing is, I've already wasted one of my chances, so I'll have to be extra careful. I did the q minus s, q minus r, q minus t. That's all I did. So I now need to multiply it by 2, which would make it, which would make it, which would make it a 2 in front, right? So it'll become 0.2, which means that this is just 20, and then we can make that 2 root 5 over 10, which is just root 5 over 5. Now let's check if that's correct, because it's root 2, which means it's root. Wait, my thing is that my computer is very low on charge, so let me just pause this. Okay, I'll be back. Okay, I'm back. So it should be root 20, root point 2, which is root. Wait, no, this was wrong from the start. Okay, let's see. So it's root um, of 1/5, which is root 5 over 5. Okay, yeah, fine, correct. Okay, we passed Vieta's formulas. That's good. What values of x is f of x equal to f of x? Okay. So basically, that's I didn't mark the last one, right? Let me mark that then. Okay, before we do this is still going pretty badly. So let's do another game of For the Win. Maybe these other people will join. In fact, if any of you want to join, you can join as well. I'll I don't want to add the link because say my computer right now the setup is a bit weird, so I don't know if I'll be able to send messages there from the computer. So just copy this link in if you want. I'll start a game. Composite, same stuff. I'll keep it to 6 players in case these people join. Let's make it 18 questions. That should be solid. Let's say I get 15 correct. That will bump this up quite a bit. 20 questions actually. 45 seconds per problem. Same thing. Okay. And now I'll start it in a minute. Okay. Okay. Let's start and let's go. Mohan is selling cookies as he decides he finds out when he bags them in groups of four. He has three left over. So it's 3 mod 4, 2 mod 5, 4 mod 7. So it's like, okay, the numbers here aren't good. 3 left over, 2 left over, 4 left over. So I think this is an application of the Chinese remainder theorem, but unfortunately I don't know how that works. So I think we'll just let this one, we let it be. Uh, yeah, we'll see the solution later. What is the sum of all palindromic primes between 11 and 200? Won't a palindromic prime be, so it'll be of the form 101a plus b. Okay, let's see. So it obviously can't be a multiple of 11. So there's going to be 11. Then we can have 111, which is not prime. 121 isn't prime. 131 works. 141 works. One, no, no, not 141. 141 doesn't work. 151, 161, 171 won't work. 181 will work. Then, okay, out of time. Restaurant has 30 tables. The first type seats two people at each table. So the second type. So 2t plus f equals 30. Total of 81 people. So 2t plus 5f equals 81. So 2t plus 2f equals 60. 3f equals 21. So that means there's 7 out of 30, which means that 23. Okay, finally. The 120 are having a meeting which said to be separated, having at least 3 but no more than 12 to a group. How many different group sizes are possible? You can have 3, 4, 5, 6. You can have 8. You can't have 9. You can have 10 or 12. Right? So that's just 7. Okay. What is the number of square units in the area of the region? So y is less than or equal to 0. Right? So we have if y is less than or equal to 0, we can have x equals 4. Won't this just be a like a circle, or is that, maybe that's wrong? No, wait, it should be like this, I think. So we can have x taking these values or x taking these values as well. This will be a length of 4, 4, and then this will be a height of 4. So it should just be 8 times 4 over 2, 16. Okay. Next, we make some more space here. In a regular coordinate thing, so if a dot is placed on every whose coordinates are relatively, how many dots will there be? So there's going to be wait, what is this? This is on every lattice point whose coordinates are relatively prime. So there'll be 3 comma 2, therefore 2 comma 3. What else will there be? There'll be 4 and 3, which means 3 and 4. There'll be won't be 4 and 2. We can have 4 and 5, and then 5 and 4. So 1 2 3, that's 6 7 8 9 10. I think that's it, right? 10, unless I'm missing something, but 10 seems right. Okay, next. A whole fish costs 4. So b equals 2 plus h, b equals t plus 1. Body, tail, head. If you add it all up, you get b plus b minus 1 plus b minus 2 equals 4.2, right? So which means that you can add it 7.2, b equals 2.4. The head should just be 0.4. Okay, wrong. Next question. There are 146 total paws. How many does a chicken have? Chicken will have, right, so each, I don't know how many paws they have. Each plus c equals 50. Horse must have 4, right? So 4h plus 2c, I think, equals 146. So 2h plus c equals half of that, which is 73. So h is equal to 23. How many chickens are there? There'll be 27 of them. Okay. What is a hundredth positive integer with an odd number of digits? Sorry, 1,000. So there'll be um 1 until 9, which is 9. We'll have from what is it, from 100 until 999, which is 1,000. Okay, that's 1,000. So 9, this is 1,009. So we can just count back 990, right? That will give us 10 plus 990. So it should be 991, right? 991. Okay, no, I think it was, then it must be okay, let's do this. -6 is less than 3x. What the hell? Oh, okay. So x is greater than -2 is less, x is greater than -2. At the same time, x is less than -2/3. So it'll just be -1. That's it. So there's just one answer. Okay. Given that A and B are the midpoints of the sides of the rectangle shown, what is the number of square inches in the area? So it's going to be half. It should be 3/8 of the answer, so 30, right? Because it's okay. Let's not be hasty about this. Yeah, it should be 30. Pretty sure. Okay. Rectangular cake pan has dimensions 9 by 5 by 2 and 3/4. Compute the number of cubic inches. Okay. Uh, these are in inches, right? So 45 times that, which is, wait, what is this? This is 8, so 11 over 4 times 45. So 0.25, right? What is this? This will just be, okay, wait, no, we can just do 90 plus 135 over 4, which is 132, which is 38. So 90 plus 38, 128.25. That's wrong. Yeah. I don't know what I did there. So much time, full 45 seconds. What is the largest positive integer with only 11 digits? With only even digits, that is less than 10,000 and a multiple of 9. So if it's less than 10,000, we wanted to have only even digits. So we can make it begin with an 8. We'll sum them all to less than 10,000. So we can only have 4 digits then, right? So we can have 8, 8, 8, and then what else? What's left? Um, we've got 24. So to get to 36, we can just have another 8, right? But no, that doesn't add. That adds up to 32, so we can't do that. Maybe we need to do a 6 then, which gives us 16, that, and then, okay, this is, see, explaining, I think, is taking time, also having to write it here. The sum of the interior numbers in the fourth row is 6. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. 1, 4, 6, 4, 1. Seventh row, right? So 1, 7, 10, 10. What the hell? Oh, wait, we can do it like 7 choose 1 plus 7 choose 2 plus 7 choose 3 and then just multiply that by 2. So 7 plus 7 times 6, which is 21, plus 7 times 6 times 5, which becomes just 35. Add them all up. 28 plus 35 is 70 minus 7, 140, 156. Okay, that's probably wrong anyway. Must be. If x increases by 1, y decreases by 3. Okay. This is going very poorly. I don't know why. What is the units of the product? So 1, 2, 3, 4, 5. They're basically 10 of these, right? So 3, 9. It's a periodicity for 9, 10, 9, right? 9. Okay. It's like a loop. The final digit is in a loop of 4. If the if x is a term in your sequence of the next term, 1/2. So it becomes 2 plus negative 1 plus half. Wait, 2 plus negative 2 minus 1. Then you do that, you get plus 1/2. Then you get plus 2 again and again and again. 20 11 times. So it becomes just 3 halves times 20 11 over 2, and then you add it again. This is like if I'd given 1.5 minutes, it would have been possible. This is not, or at least some more time. I'm taking too long on these. If 4 times k is added to 88, so 36, 9, 81, right? K is 9, so 36 plus 8, 44, 9, 81. Okay. Going very badly. The third number in geometric sequence is 1.5 and the common ratio. So 1/2, 1/2, 1/2. So driven 6, 3, 1.5, 0 0.75, 0 0.375. Let's do this quickly. So it becomes 9, 10.5, 0 0.5, 0 0.75, 0 0.375. So this becomes 5, 2. You can put a 1 there, which will make this 12, 16, 17.1. So 11.12.225. What is it? 12? How is that wrong? 12.225. And the number t is attention. What makes it a number multiple of 11? So 3 minus 4 plus 5, negative 1. Right, wait, negative 1 plus 5 becomes 4. 4 minus something, 8, 12. So it should just be 1, I think, right? Because 3 minus 4 will become negative 1. You do plus 5, you get 4. You do minus 1, and then you do plus 8. So, right. Wait, it can't be 1. It's just, yeah, 1. I was about to write negative 1. Okay, yeah, this was very bad. First one, fine, I didn't know that one. This one was, you just had to add them up, right? So you have 11, then you had 131, 141, I think. No, not 141. You had 151, 161 as well. I'm No, not 161 because that's actually a multiple of 7, right? So 181, and then I think 191 maybe. Then there must have been more as well. Actually, there are probably a lot more. All the like 3 something, those ones could have worked. 5, 7, 9. So a lot of them could have worked. Okay, this one we got correct, thank God. Same with these ones. Okay, I think I just wrote it badly, but this was correct, so I will keep that as correct. How many have I gotten so far? So done, done. Okay. Problem one wrong, problem two wrong. Then one, two, three, four, five. This one is correct. Six, seven, eight. Okay, so not too far off. I know what I did there. Eight. Oh, yeah, what did I? In the fourth row, so four. Wait, in the fourth row of Pascal's triangle. Oh, seventh row isn't the one with the sevens in it. It's the fourth row is 1 3 3 1, right? So it becomes 1 4 6 4 1. That's the fifth. Then the sixth becomes, so it'll just be like six, choose one, plus six, choose two, plus six, choose three. Then you just do this. So I think you do twice each of these. So this becomes 12 plus 6 choose 2 is what? 6 times 5 over 2, 15. So this becomes plus 30. And then 6 choose 3 is just 20. And that adds up to 62. Okay. I did it for the next row. I did it for the eighth row by mistake. This one is wrong. Fine. Uh, that was just a calculation error, I think. Okay, and this one was actually pretty bad. I should have figured that out. I was on the right track with the 8 and 8 in the beginning. Then I tried to go further with that, which doesn't work. Wait, how many is this? So I got one, two, three, four, five, six, 7, 8, 9, 10, 11. Yeah, how did I mess this one up? 12. 12, that's it. Okay, that's actually horrible. Last time I got 11 out of 12, this time I got 12 out of 20. And I don't think the questions got any harder. Right, anyway, 12, so uh these people are still over there. Anyway, let's do something else that's not too bad. It should be fine. Basic polynomial roots. Let's skip this. Let's find another good one. Another one that shouldn't be too hard. Let's say exponents and logarithms. That should be good. Actually, this isn't looking good. So w to the wait, let's think about this. So that's a base, and then so 24 to the x is equal to w. Okay. 40 to the y is equal to w. And then we've got 12 to the x, y, z is equal to w. We need to find the value for which any like random value, let's say alpha, or let's just say a, whatever, to the z is equal to w. How can we do this? Well, if we multiply, I think we'll just divide this thing over here by those two. But how will we do that, right? Uh, okay, I don't want to be like that, but we're still like very far behind where we should be. So let's skip some of this. Let's do let's take a look at radicals and see. No, not this one either. Like just something where I can get some like, a lot of questions done pretty easily. Okay, let's do prime factorization. In the prime factorization, okay. So it'll be how many multiples of 3 are there plus how many multiples of 9 and so on. So you just keep on doing that. 109 over 8 gives you 36. 36, 12 for, so 36, 12 for 1. Add it all up, you get 4853, right? Okay. What is the sum of the different prime factors of this? So let's take out a 2 and a 5 right away. 2 times 5. uh, 2 times 5. We can then, uh, what else can we do? Then we've got 15,028. Let's see what all goes in here. We've obviously got a 4, right? So we can just keep these right now because we're just being asked for different prime factors. So let's divide this by 4. What does that give us? Well, it'll be 7, right? That's a 28. Then 15,000 will just be 250 times 15. 250 times 15. Uh, that's 25 times 15, which is, what is that? That's going to be 400 minus 25, 375, 3750. So 3757, right? Is this prime or not? I don't know. Okay. Yeah. Let's see. What else does like 7 won't go in this, right? That's 257 and 7 won't go into that. Um, what else is there? I don't actually go and check all of the. I guess that maybe that is prime itself, right? Maybe I I think that's prime. So anyway, let's plug it in then. 3764. Okay. Wait, did I even do it correctly actually? Let's check. If you multiply it by 4, you get um 20, 28, 200. Okay, that it seems right. Right, 375 times 4 will give you 1200, 1500. Yeah, that's correct. Now, then obviously that must be a prime factor. There must be some other prime factors in that. Let's see if we find any. What about 13? We'll have to check all the primes until almost 200, I think. Oh wait, no, sorry, this is only 3000. So we only have to check uh until maybe like 40. No, not 40, 50, 60. So just check until like 61 or something around there. Right? That's all we have to check until. Can't be 61, can't be 59. Okay. Um, for the sake of time, let's give up on this one then. Let's see. 3757. Okay, it's got 13 in it. 3900 and then 17. Okay, so it did simplify nicely, which I didn't know. Okay, let's keep marking though. I'll create a small post-it closer to where I'm working right now so that I can keep track. Where are we? Here. Okay, let's work over here. What is the positive difference between the two largest prime factors of this is like I don't want to be doing all these sorts of calculations. It's kind of it just takes a long time. What is the GCD of all members of the set containing all numbers that are the product of four consecutive positive integers? So for four consecutive positive integers, you'll have um x, x plus 1, x plus 2, x plus 3. At least one of these will be a multiple of 3. Obviously, at least one will be a multiple of 3. One will be a multiple of 2. One will be a multiple of 4. So it'll just be the product of all of those. Right? Oh, also you could just do 1, 2, 3, and 4. That would also work. Right? So this will just be 824. So multiply them up. Two ropes, 18 need to be cut into pieces which are the same length. What is the greatest possible length of each piece? It should be 6, right? That's the GCD. What is the greatest common divisor? Um, 11. 11 and 13 actually. Because 1001, so 11 times 13, which is 143. No? Okay. Uh, what is it? It's 7 times 13, which is 91 times 11. 13 is just, oh, it's a multiple of 11, but I don't think it's a multiple of 13. No, obviously it is a multiple of 13 as well, the greatest common divisor. 13 times 11 is 143. Okay, first of all, how many questions have we done here? I think it's two, right? Two questions so far. Um, this has to be a multiple of 11 because it's 1 minus 3 plus 1 minus 3. Oh, it's not. It's not. Okay, never mind. I did that wrong. Instead, this should be a multiple of 13 then. So it should just be 13. Okay. What is a same question again? What is the positive difference between the two? Oh, because we passed it. Let's go back there and do some more. Find the product of the greatest common divisor and the least common multiple. That's always just equal to the product of the two numbers. 1, 2, 3. So it'll just be that. That's 4. Let S be the set of all three-digit numbers formed by three consecutive digits in increasing order. What is the greatest common factor of all three-digit numbers in S? Okay, so one will be a multiple of 2, one will be a multiple of 3, the other one will be a multiple of 4. So this will again be 24. Hmm. Oh no, no, what if you begin with 1? Then you have 1, 2, and 3, so it will just be 6. Wait, what is this even asking? Let S be the set of all three-digit numbers formed. Oh, wait, I misunderstood. You're not multiplying them at all. You're basically doing 100A plus 10 times A plus 1 plus A plus 2, right? Which will basically give you 100A plus um plus 10A plus A plus 12, right? 100A plus 10A plus A plus 10 plus 2, so plus 12. 111A plus 12. Now, depending on what A is, if A is even, then it'll obviously be 2 or something else, at least 2. But if A is odd, then it won't really be any. Oh, wait, then it'll be 3, right? And it has to be 3, in fact, because. So it should just be 3. Since 3 consecutive numbers, they'll always add up to a multiple of 3. This is a fifth question, so it'll be a line here. What is the sum of all two-digit positive integers whose squares end with the digits 01? So it has to either end in to end in O1. How do you get that? Um, so there's obviously 2401, right? What is 2401? What's the square root of that? It's I think that's 49, right? Which is 7 to the fourth. But in general, like 29 won't have the same thing. So it'll have to end in either a 1 or a 9. But 11, 21, 31, 41, 51, 61, none of them will end in O1. If it ends in a 9, 39 is going to be, well, what will it be? It'll basically be 10a minus 1 whole squared, right? And so the only way this will work, oh, 99 will work because 99 is 98 over 1. And basically the thing is that when you expand this, you'll get 100a squared minus 20a plus 1. So you need a to be either 5, 10, or a multiple of 5. So that, like, 100a squared is far away. It's like not in the tens or units digit. This will become 0. Or this also won't be, this won't be in the tens or units digit, and you're just left with 1. It has to be something like that. And actually then the same logic should apply for plus 1, 10a plus 1. This will just change to a plus. So same exact thing. 51 should work and 101 should work. 101, obviously we can't do that. So it'll just be, I think, 51 then. Right, and let's actually check that once really quickly. 25, this becomes 5, 10, 0, 1. So 1, 0, 6, 2. 2601 seems about right. Oh yeah, that's correct. So it'll be 199. Correct. Given that a is a multiple of 1428, find the greatest common divisor of a squared plus 9a plus 24 and a plus 4. Okay, so 1428, you can take out a 14 from there, which will give you 102, isn't it? 102 times 14. 102 is 2 times 51, and 51 is 17 times 3. So it's 2 times 3 times 17 times 4 times 7, and then this becomes 2 squared. So 2 squared times 3 times 7 times 17. Find the greatest common divisor of these two. A squared plus 9a plus that is just, oh, it's a multiple of this. So it's this times a. If you square it, well, let's see if we can do something with these two. A squared plus 9a plus 24 is a plus 4 squared plus a plus 8, right? Yeah. So, okay, I don't know. This is, oh, this is a Euclidean algorithm. Okay. I wanted to go back to the greatest common divisor one. Okay, wait, let's see. Let me master these two then. At least get some blue stuff here. What is the greatest whole number that must be a factor of the sum of any six consecutive positive odd numbers? If they're consecutive odd numbers, so let's just take the base example 1, 3, 5, 7, we need 6, right? So 9, 11. If you add them up, you get 12 here. Will you always have that? Yeah, you'll just, there's 6 of them, you just have plus 2, plus 2, plus 2. Right, so over here you have now, this adds to 12, this adds to 12, this adds to 12. 12 times 3, 36. But next time it would be 46 if you just shift everything um up by 2, right? And then, so it'll just be 12. That's the common factor. I might have missed one or two of these, one or two of the questions. I'm not sure. Remainder. Okay, let's leave it. I think now what we need to do is um really pick up the pace. So I'm not too proud of this, but we're going to go to math count trainer, and we're going to go to the very easy. So we'll go to the school mode. Just do some questions there. This is kind of similar to the for the win stuff, right? It's just like extra practice or whatever. In one round of a TV game show, 3 questions are asked. The second question is worth twice as much as the first. It is worth thrice as much as the second. So it's 6, 9. The third one is worth 9. The first question is worth, mm, well. Oh, hi Aaron. How are you? Do you have summer break already? Okay, let's see. So, 3 questions are asked. So it's just A, 2A, 6A. So it's just 600. Oh, wait, 2000. Very stupid. Okay, I think. Wait, let me check one thing. So if I check this, today we've only done one question. So we can see total questions. We can see the total questions just by checking this. So I'm not going to bother writing it down. What is the value of f of 100? So it'll be 9. So it'll just be 3. Oh, wait, really? Nice. Okay, correct. So I have a total of 1020 widgets. He has half. Kevin has 290, which leaves you with whatever. What is it? 801. He has half the number that Cindy has. So Cindy will have 2/3 of the 801, which will just be what, 300 minus 99, so 267 times 2, which is 520, 534. I think that's wrong, but okay, good. Right. At least I'm glad I did that in my head. Okay, the square root, right? So that becomes 100, which we can take out 8 and then 18, 18 and 8. So it becomes 16 times 9, which becomes 4 times 3, 12. So 120. The sum of two numbers is 12 and the difference is 20. So a plus b is 12, a minus b is 20. So 2a is equal to 32. One of them is 16. So the other one will be -4. Right? Should be. Yeah, it's a bit slow. So let's check. Let's refresh it. Oh, doesn't really matter. We'll just go back. I think these Ben the Greatest and STEM Rocks have been here for like the whole time I've been online. So let's see. How many questions now, roughly? Let me add these. What, 7? I'll add them over here and see. So So far we've done I think like almost 40. If math counts trainer continues, we should be able to finish it off pretty quickly. Like once I get to 85 questions, and maybe we can go back to hard ones again. But I think 100 is far too much. Okay, good. What is the 10th positive? And did they add that fifth one? They did. Great. What is the 10th positive integer that is both odd and a multiple of 3? So, 10 positive. So basically it isn't a multiple of 6. So it's the 20th multiple of, no, it's a 19th multiple of 3. Um, which means it's just going to be 57, I think. Okay. If m, whatever that operation is, okay, 2m plus n and m whatever is okay, let's just do this stuff. So it becomes 17, so 2 delta 17, let's say 2, so 421, I think. What is the median of the first 10 positive integers? It'll just be like 5.5, right? 110. So in the middle you've got, yeah, that's 10 numbers, so it'll be 5.5. What is the least prime number greater than 25 that will have a remainder of 2 when divided by 25? So it'll be so it won't be 77. 127 might work. I think 127 works. If that's prime. It is. Okay. There are 14 cats, so there'll be 21 dogs. What's the positive difference between 36 and 26? It's 10. What is the value of this quotient? So it's 12 minus 9. Um, sorry, what? 12 minus 9, 3. No, no, no. It's just 1/9 divided by 1, right? 1/9. Wait, sorry, the denominator is just 1/9 as well, I think. Sorry, it's 127, so it'll be 3, 3, 3, 3. I meant to put in 3, so I'm just going to add 1 over here then, since it won't show up over here. It was supposed to be 3. I accidentally put a 1 before that. 4, so 3. In right triangle ABC, what is the arithmetic mean in degrees of the two smallest degrees? It'll be 45. A horse 24 feet from the center of a merry-go-round makes 32 revolutions. In order to travel the same distance, 8 feet, you just have to make 3 times as many, so 96, I think. The perimeter of a triangle is this and that. What is it? If they're integers, then then we can just take 8 and 3, I think. So it'll be 3. Yeah. The sum of 5 consecutive integers is 185. So what is the mean will just be dividing it by 5, which will give you what, 91? No, not 91. 36. So 37. The product of the integers from 1 to 7 is equal to this. What is the value of j minus k? So how many 2's are there? Going to they're going to be 3, 4. 4 is j. K is just equal to 2. 4 minus 2 is 2. What is the product of the least common multiple and the greatest common factor? Okay, 1800, because it's just the product of the two numbers. What's the least common multiple of all this, like all of these? You can take out, well, you can't really take out anything, right? There's nothing in common with all three of them. So you'll just have to multiply them all together, I guess, which gives you 70. So multiply that, that gives you 9800. Wait. Well, I guess you don't need there to be any, that would be for the GCD, which is what was confusing me there. Okay. Let's see, how many have we done? Already 18 questions. So that's why I wanted to do this. Let me not add them yet. No need to do that yet. Let's continue. Wait, how long has this stream gone? Let's see. It's been about an hour, I think, right? Something around that. Uh, yeah, wait, 1 hour is actually quite a bit, so I don't want to take too much longer. In a recent, wait, I can check how long exactly. 1 second. Yeah, 1 hour and 40 minutes. So that's quite a bit. Let's try to finish this in like half an hour more. In a recent year, the number of was 45,000. There were 3 million visitors to Palm Springs. What is the so you just divide it, which will be 3,000 over 45, right? 3,000 over 45. Right now, I was trying to do them all mentally, but that's not feasible anymore. 3,000 over 45. Um, that's 300 over 45, but that can't really be. You can take out you can't take out a 9 either. Express your answer the nearest whole number. So you can take this out. You can take out a 3 from here. You can take out a 15 from here, which will just make this 200 over 3. 200 over 3 is 67. No, it's 66. And remember, there's 1,000. Wait, yeah. So it's just going to be 167. 166.6666. So it should be 167. 18 out of 20. Let's refresh and see. Uh, we'll, what is it? 167. Oh, horrible. Yeah, it's 66. So 67. Moon scored 40 points lower than Foof. Foof's score was double Cook's score. Moon scored 32, so 72. So 36 for him. Chris has twice so much money as Ivan. Tay has 4 less than Ivan. If Tay has 8, Ivan has 12. Chris has 24. 24 plus 8 plus 12 becomes 44. What is the sum of what is the reciprocal of the sum of the reciprocals? So the sum of the reciprocals will be 9 over 20, so it's 20 over 9. Okay, not bad. Nothing bad happened there. Wait, did they mark it as wrong? I think they did. Probably because I refreshed it or something. I'm pretty sure that answer was correct though. Okay, 6 blops equals 1 glop. 5 glops equals 7 flops. So that's 15 glops. So that should be 90 blops, right? 90 blops. Okay. What digit must be placed in the blank to make the 4-digit integer 20, 7? So it's 2 minus 0 plus something minus 7. Should be 5 then. Okay, wait, how about this? For whatever question is going on, you can write your answer. Okay. This histogram shows the what is the median number of hurricanes per year reaching the east coast. Just kind of eyeballing it. Uh, okay, 5, 14, so that's 19. 19 plus 17, so 36. So I think it'll be 2, right? I'm pretty sure it's 2. Maybe it's 3. Okay, 2. Angie decided to use her class as a sample to predict the total number. She counted 11 students wearing red in a class of 24. So out of 200, so it should be 220, right? What is the value of 8x plus 2? 4x is negative 8, so negative 62. I multiplied it by 8 instead of just by 2, so that was my mistake. What is the number of sides in a also guys, check the chat. You can like race against me or putting your answers in. I think there's some sort of lag between like the chat and the stream, so that might cause some problems, but it should all be fine. And this one should be 10. Just yeah. The angles are in this ratio. What's so out of 9, so it should be 100, right? Okay, in this factor tree, each value is a product of the two values below it, unless a value is a prime number already. So 6. What is the value of a? So 18. 18 times 50, so it should be 900, I think. 30% of x is that. What is 40% of x? So it'll just be 4/3 of that. 1/3 of that will be 4115. So it'll be 41115. 4115 times 4. So that becomes 16. This becomes 460. 16 460. If the legs of a right triangle measure 0.3 units and 0.4 units, 0.5 units. Bill buys a 32-ounce bottle, 40-ounce bottle for 2.5 cents per ounce. That costs 196, so costs 4 more cents. In square units, what's the area of the gray triangle? So it's 6 times, well, it's just 6. Sum of two integers is 75. One is 3 more than the other. So, oh, 72, 36, 39. 4 workers can build a stage in 10 8-hour days. Just skip the 8-hour part. How many workers will it take to build the thing in 5? So it'll be 8, twice as many. What is the value of all this stuff? So it's out of 9 basically, and you're just adding up 10, so it becomes 10 out of 9, 10 out of 9. So I'm marking that as correct since I did it correctly. I just yeah, I made a typo there. The perimeter of a square is 44 meters. How many square meters? So that's 11, so 121. This graph shows the number of days in October that Carla studied for particular periods. On how many days did she study 3 or more hours? So 10 plus 6, so 16 days. If Mark drives for an average, if Mark drives for 4 hours at 60 miles per hour and then drives another 6 hours at 40 miles per hour, so the distance he's doing is the same, right? It'll be 240 miles in both cases. So he's done 480 miles in 10 hours. So it'll be 48 miles per hour. Yeah. This box and the box and whisker plot shown details the shoe sizes of a group of women. What is the median shoe size for this group of women? Median is just 8, right? The combined number of chickens is 100. There are a total of 260 feet. Chickens and rabbits again, right? So chickens have 2 and rabbits have 3. Sorry, rabbits have 4. So there are 30 rabbits. So that's 70 chickens. What is the value of the 21st term? So it will be plus 20, so plus 181. 150, which is 75%, so it's 4/3 as much, which is 200. 12-hour analog clock, 12 and 8. So that's 120, right? The length, let's check how many. I'm guessing about 35 right now. Okay, 40. That's actually great because we've already done, this is 30, 40. So now we're like 81% up. Let's let's get to 95, then I'll do some hard questions again. The length of a rectangular playing field is 3 times the width. If the perimeter is 96, that means that it's 48, which means it's 12 times 36, which means it's 12 times 36. 360 plus 72, which is 432. That's wrong, I think. Okay, correct. If uh, 6, so it's 36 of 40. Again, okay, let's wait until it actually loads now. I think that will be better. Okay, still not working. Just a bit. Okay, 40, finally. A scale drawing of a park shows that 1 inch represents 800 feet. A line segment that's 4.75 inches will be 475 times 8, which is 6 plus 32. So 3,800 feet, right? It should be. Um, okay, this is getting a bit slow. I'll see. After this question, maybe I'll just refresh the page. That could help. Okay, what is it? 3,800, right? Okay. The product of three consecutive odd positive integers is 7 times the sum. So, odd, right? So we can say, we will write for this one a little bit. Odd positive integers is 7 times the sum. So the sum will be, so 21a is equal to a times a squared minus 4. What is the sum of the three integers? 5, 15. I guess it's 15, but let's be safe. Yeah, 15, I think. No, no, no. Okay, this one should be 15, but if you have to refresh, then fine. Okay. A club had collected an amount of money to split among the top three finishers of their annual science fair. Annual science fair. The first place finisher will receive half of the money. Second place will receive one third. The third place finisher will receive this much. Okay. So that's 1/6. So he'll receive 3 times the amount. So he'll receive 600. On planet Lucky, whatever, how many legs are equal to 80 lugs? So that's 436, 963. It was 9. So it'll be 81 cents, 162. So it'll be 1062. Wait, what? Oh, if the tip is 9. Okay, that's dumb. My bad there. What is the median of the set of all positive factors of 100? All positive factors. How many factors are there? Wait, we can use the rainbow method for this, I think, right? So there'll be 1, 2, 4, 5, and then 10. But it'll just be 10 because it's a perfect square, so it should just be 10. And in general, then for any perfect square, the median of the set of all positive factors will just be its square root. Sami remembers that the digits in a new area code contain a 987, 6 factorial, sorry, 3 factorial, so 6. What is the smallest integer length in units for the side of a square so that the numerical value of its area is greater than the numerical value of its perimeter? Wait. Smallest integer length in units to the side of a square. Set the numerical value of its area. Um, 3, right? Sorry, no, 4, 5. So it should be 5 for this. At 4, they'll be equal. Um, Suppose a and b are positive integers, and you have this. What is the value of a squared plus b squared? You can just multiply it out by 12 directly, but that's not really ideal, right? You get 3a plus 4a. Wait, how do you do this actually? If you multiply it by 12, you get 3a plus 4b is equal to 13, right? What is the value? Oh, if they're positive integers, then it should be easy to figure out. One of them will be 4. So a is equal to 3, b equals 1. That'll give you 9 plus that. So if you square them now, you get, and add them, you get 10. When he was 5, his allowance was 25. When he was 6, his allowance was 30. When he was 7, at age 11, so it'll become 2. At 8, it'll go to 16, right? Okay. Each row of a seating arrangement seats 7 or 8 people. 46 people have to be seated. Okay, so you can have 40 and then you do 6 sevens. So, no, sorry. Six. So there'll be 4 with 8, which means 32, and then there are 14 left. So there'll be 4 with 8, 2 with 7. We could have set up a system, but I did something in my head. I think I guessed, but that seems correct to me. It's very slow. They're not going to give that same error now, I think, if I refresh. I will refresh though. This should be 4. It's been 2 hours now. This is becoming pretty slow, I think. Okay, 52. And we've already done what? 41. So that's 93. Let this go, I think. Let's do a quick. Um, okay. Each side is doubled in length. The perimeter is 40 on each square centimeter. 40, 10, 20, 400. Right? 100. And then if you double everything, so from it'll go to 20 times 20. So 400. But let's try this one actually. This is a harder question, I guess, but it'll still be good to do. Right, this is from the thing which we were doing all the way in the beginning. The Okay, let's see. So game A and uh correct again. Oh, wrong. Oh, is double the perimeter of EFGH. Okay, I did that completely wrong. Um, five, 5. This is 5. I'll put 1 here. Typo. No, I don't want to do this, but okay, but let's do this actually. So out 2 nines plus 5 over 81. This becomes 18, so 23 over 81. The angle measures are this, so it's like half, third, and sixth. Smallest angle will be 30, right? 30, 60, 90. Yeah. 25 plus 3, 28. What is the product of all positive integer factors of 15? Well, how many sets are there? It'll just be 15 to the power of 2, right? Because it's just 3 times 5, so 15 to 25. You could have also listed them out, but I wanted to be, you know, okay. So if you're raising the whole thing, it becomes to the fourth power, which means it just becomes 4. Two consecutive integers is this 19 and 20, so 39. Okay, I think we've crossed the thing now. 59. Yeah, we've just done 101 questions now between all of this. So I should plus 59 equals 101. So we've now the goal is done. Uh, I won't end the stream just yet though. I want to kind of at least do this. I'll end this part. This is quite a few questions. I'll leave that. Let's do this last question and then we'll end it because this has been very long. Okay. So game A. So a player has a choice of playing in game. In game A, she crosses and wins if all three outcomes are the same. So that will be 2/3 cubed, right? If you get the heads 3 times, or if you get 1/3 cubed. So this is the probability of A happening, which becomes 8 plus 1, so 9 over 27, which is equal to just 1/3, right? Now let's look at probability of event B happening. You toss it 4 times, so you either have 2/3, 2/3. Let's just do all the cases. You can have 2/3 squared and then 1/3 squared. You can have 2/3 to the fourth power. You can have 1/3 to the fourth power, or you can have 1/3 squared and then 2/3 squared. Obviously, these two are symmetric, right? So we can just write that as well. Let's actually just quickly evaluate that. Yeah, let's do that. So that'll be over. So that'll be 4/9 times 1/9, 4 over 36. Sorry, 4 over 81. So that becomes 8 over 81. Then we have plus, this becomes 16 over 81, right? 16 over 81 plus 1 over 81. Adding it up, you get 25 over 81. So this is equal to 25 over 81. Now, based on whatever they're saying here, the answer should be D, I think. It should be D. Because it's 27 over 81 or that one. And yeah, the answer is indeed D. Which are the following? Oh wait, this seems too easy. You can just put it all in terms of the whatever the least common denominator, which is so A is 8 over 24, that's 6 over 24, that's 9 over 24, that's 10 over 24, that's 7 over 24. So it's D. AJHSME. So what I don't know what that is, but this is very easy. So D, definitely. Amy number 11. A token starts with a 100 and then makes a sequence of 6 moves. Each move selected randomly and independently. The probability that the token ends at a point on the graph. Okay, wait, let's take a look here. Um, it begins here, and you basically have this, and you have this. How many total squares can your thing go to? Right, you can go. There are a total of how many different lattice squares that you can wait, that's what it's called. How many total points can you go to? Well, it's kind of hard to think about actually. The you can't go to you can't go exactly 5 points away, I'm pretty sure. Like that would be impossible. Like you can't go one, two, three, four, five. Because you have to do 6 moves and you can't waste one move. You can waste 2 moves, but you can't waste one move. So that's not possible. One thing we can do is just like do 1/2 times whatever the probability is, and then just calculate it for the top here. But then again, we also have to, or maybe we can just do it for this quadrant. But we also might have to consider the lines themselves. So this is a, and this is an Amy question. I didn't even notice that. So this one isn't going to be too easy. Let's skip it for now then. Okay, how long? It's already been well over an hour, so I don't think there's any reason to go for longer. Okay, yeah, I think that's enough then. So that's it. I think we did like 103 or 104 questions. Obviously, the vast majority ended up being easy questions, but we at least did some hard ones. So that's it then. I'll end the stream now. Thanks for watching, and I'll see you. I'll see you guys soon. Bye.